Vocabulary of the day: system of linear equations, defined as two or more linear equations with the same variables. We're in 6.3, solve linear systems by adding and subtracting. Before, we solved systems of linear equations by graphing and substitution. Today, we're going to solve systems of linear equations by elimination. We're going to try and eliminate the x or the y variable. To do that, we're going to be looking for opposites. 3x and negative 3x, for example, would give us 0 when combined. So our goal today is going to be looking for opposites so that we can eliminate either the x or the y variable. These steps, key concept is in your book. First step, add or subtract the equations to eliminate one variable. Instead of subtract, you're going to hear me say add the opposite. I find most people get the addition easier than they do subtracting, so we're going to talk about adding the opposite. Solve the resulting equation for the other variable. Substitute into either original equation to find the value of the eliminated variable. It's important that you always go back to the original equation for that substitution step. Here is our first equation. I would advise you, as I'm writing this out, for you to think about what are our opposites. What variable can we eliminate in looking at this equation? So I look for opposites. I see negative 3y and positive 3y. So we're going to continue to solve this by adding. 5 and negative 7 would give us negative 2. Negative 3y and positive 3y would give us 0. And 4x minus 2x is going to give us 2x. So we have this simple equation, 2x equals negative 2. To solve, we divide both sides by 2. X is going to equal negative 1. We're going to take that answer up here to either of our original equations. I'm going to choose to work with the first equation. 4x minus 3y equals 5. 4 times negative 1 minus 3y equals 5. Negative 4 minus 3y equals 5. We're going to add 4 to both sides. Negative 3y equals 9. Divide both sides by negative 3. The value of y is going to be negative 3. 9 divided by negative 3 is negative 3. So our final answer in this case, the coordinate point, negative 1, negative 3. Looking at this second set, again, let's focus on looking for our opposites. Here are our two equations. If you look carefully, you will see that our x variable is listed as opposites. So we're going to combine these by adding. 8 and 4 would give us 12. Negative 6y and 2y would give us negative 4y. And again, opposites, negative 5x, positive 5x is going to give us 0. So negative 4y equals 12. Divide both sides by negative 4. 12 divided by negative 4 gives us a value of negative 3. Take that value into either of the original. I'll use the second one in this example. 5x plus 2y equals 4. 5x plus 2, instead of y, I'm going to put in a negative 3. Oops, let's try that again. Equals 4. 5x plus a negative 6. I'm going to actually stop there and fix that. What I had was 2 times negative 3, so it would be 5x minus 6 equals 4. We're going to add 6 to both sides. We have 5x equals 10. Divide both sides by 5, and our x value is 2. So the coordinate point, the solution is 2, negative 3. Looking for opposites in this example, we have 6x minus 4y equals 14. Negative 3x plus 4y equals 1. My opposites appear to be here with my y variable, so I'm going to add. 14 and 1 would give me 15. Negative 4y and positive 4y is 0. 6x minus 3x is 3x. Our linear equation, 3x equals 15, we'll solve by dividing both sides by 3. Our x has a value of 5. Picking either equations, I'll stick with the first one on this one. Your choice. Can get the correct answer by substituting into either original equation. 6 instead of x, I'm going to put in 5. minus 4y equals 14. 30 minus 4y equals 14. If I subtract 30 from both sides, minus 4y equals negative 16. Divide both sides by negative 4. The value of y, negative 16 divided by 4, would give us, negative 16 divided by negative 4 would give us a positive 4. So our final answer here, our x value is 5, our y value is 4. In this example, and this is where we're going to talk about subtracting as adding the opposite. Here are my two original equations. And if you look, I do not currently have any opposites. However, my x variable here, my x variable has the same coefficient. So in order to get opposites, I'm going to subtract, or as I prefer to call it, add the opposite. So my original, sorry, my mistake. Let's fix that here. My original top equation is staying the same. 7x minus 2y equals 5. Now I'm going to take the opposite of my second equation. The opposite of 7x would be negative 7x. The opposite of negative 3y would be plus 3y. The opposite of 4 would be negative 4. Before I continue, I want to explain what I just did. I subtracted this entire expression by distributing, if you recall the distributive property, a negative 1 over everything inside the parentheses. So now that I've rewritten it, we are actually adding. So 5 minus 4 would be 1. Negative 2y plus 3y would be 1y. 7x and negative 7x would be 0. So simple answer here, 1y equals 1, so the value of y is 1. I can pick either original equation and substitute that in. 7x minus 2y equals 5. 7x minus 2 times 1 equals 5. 7x minus 2 equals 5. I'm going to add 2 to both sides. 7x equals 7. Divide both sides by 7. The value of x is 1. So my final answer, the coordinate point, would be x comma y, 1 comma 1. Today's assignment is on page 389, problems 3 through 14.